Hello and thanks for watching. Open-appsec is an open-source initiative that builds on machine learning. It provides preemptive web app and API threat protection against OWASP Top 10 and zero-day attacks. Open-appsec is designed for simple setup and painless maintenance. Thanks to machine learning, there is no threat signature upkeep and exception handling like common in many WAF solutions. It can be deployed as add-on to Kubernetes Ingress, NGINX, Envoy and API Gateways. In this tutorial, we will show how to protect web applications and APIs in just a few minutes. We will use a demo web application called Acme Audit that has multiple security vulnerabilities. You will learn how to attack the application by performing a SQL injection, a simple attack just for demo purpose, deploy NGINX as reverse proxy that will serve the application, deploy open-appsec for NGINX to protect the application, attack the application again to see that the protection is effective, and finally, connect your deployment to the SaaS Web-Based Management. By the way, you can run this tutorial yourself by choosing the playground option at the top menu of open-appsec.io. Acme Audit application is vulnerable to a SQL injection attack that allows bypassing its authentication mechanism. Let's try to take advantage of this and log in without having an account. I click here to launch the application. First, let's try to log in with an arbitrary username and password. This fails. I will use a string that will trigger a SQL injection. As you can see, the application is vulnerable. I was able to log in and reach some confidential info. Let's deploy NGINX as reverse proxy that will serve the Acme Audit application. I run the install command. As you can see, NGINX is live. Now add the Acme Audit application, which listens to port 8080 to NGINX. I reload NGINX and verify that the application is accessible via the reverse proxy. All well. Let's deploy open-appsec. Open-appsec deployment is rather simple. I download the installer package and run it with the auto command so it will find NGINX and add itself. That's it. It is running with a default policy. Additional information about the policy and various control commands can be found in the documentation. Here. I browse to Acme Audit application again and try to enter the attack string. This time the attack is blocked by open-appsec, and I get a 403 HTTP error code. The logs are available using this command and include attack and traffic details. At this point, I have a working deployment of open-appsec. I can manipulate the policy using configuration files and obtain logs. As the policy is available as code, I can store it in Git and deploy using our CI/CD process. In the next step, I will connect the deployment to the central SaaS-based management, which provides policy editing using web user interface and advanced situational awareness tools that are useful for large deployments. I browse to my.openappsec.io and sign up using my GitHub account. This is Open-Appsec Management Portal. I check this box as I already have an agent deployed and choose NGINX profile. The on-screen instructions are advising to enforce the policy. I copy this CLI command, which includes a token to create a secure communication channel between the open-appsec deployment and the cloud. I paste it here in the Linux shell and wait. That's it, my deployment is now centrally managed. Let's go back to the management portal and see the policy that I defined before using configuration files visualized in the web user interface. You can see here the default asset that covers all traffic. Here are the security settings. The last step is to see how logs are visualized in the web UI. I will repeat the same drill of triggering an SQL injection attack. Let's observe the event. This dashboard provides at-a-glance traffic statistics and information about attacks. I can drill down by clicking on any of the widgets to see the actual events. The table shows the relevant events. For each event, I can see further details, such as the HTTP request details, attack source, attack type, and payload that triggered detection. I can also track the learning process, but more on that in another tutorial. Thank you. You can run this tutorial yourself by choosing Playground from the website main menu.